Hey y'all, I miss you. I suppose you're getting sick of me hearing me say that. Okay, today we're going to learn to find a power series for a rational function by recognizing the function as the sum of a geometric power series. So first of all, let's review geometric series. A geometric series is in the form the sum from 0 to infinity of a times r to the n, where a is the first term and r is the common ratio. Suppose I told you to start with a equals 2 and to let r equals 3. What geometric series would you write? And that should have been fairly straightforward. If we changed the r to a -3, we would include that -3 in the parentheses. And if we change that r to an x, we would simply write an x in the parentheses. We know that these are geometric series, so we can actually create a power series for the function. So we can, I don't know what I'm saying. We can use our knowledge of geometric series to help us write a power series for a function if the function can be written in the form a over 1 minus r. So the sum of the power series, that last power series, we could write a over 1 minus r or 1 over 1 minus x. And we see that the series that we began with sums to a function that we're very familiar with. Okay, so if we have a geometric series of the form n equals 0 to infinity, a times r to the n, it will always converge to the sum a over 1 minus r, where a is the first term of the series and r is the common ratio. If the absolute value of r is less than 1, the series converges. I already said that, but I felt like I lost track of what I was saying, so I had to re-emphasize it in case somebody else did. And the geometric series diverges if the absolute value of r is greater than or equal to 1. So we need to find power series for 1 minus x squared. Notice that it's different than the other one. It's not 1 minus x, it's 1 minus x squared. Well, what this means right here is that your r is actually x squared. What's your a value? Your a value is 1. This is going to be centered at x equals 0. I am going to give the first 4 non-zero terms and the general term. And we are going to figure out for what values of x does our series converge to f of x. Every single time over the years, every time I do this problem, I land right on the series, and I always forget to do the interim steps. So what we really have going on here is a series of functions, and I'm going to write them down using the power series. Okay, if you look at all of these terms, you will see that the numerical terms actually cancel out each and every time. So we actually have a fairly simple series in front of us. And this series converges when the absolute value of r is less than 1. Well, our r value, if we look at this series in the form that I always see, I don't know, my brain just jumps to that right away. If you look at the series in that form, I'm sorry, I was able to jump to that. I feel like I should address that because I'm super familiar with geometric series. It was something that used to be emphasized quite a bit. I did not write that right. It was emphasized quite a bit in the pre-cal curriculum up until about 5 years ago. Series is super useful in want to say stats, but I might be wrong. It might be mostly calc. In any case, I see immediately that my R value is x squared. So I'm going to use that information up here that states that the absolute value of R must be less than 1. And I'm going to look at the absolute value of x less than 1. And I'm going to solve, x squared less than 1. And I'm going to solve for x. Well, this means that x squared is somewhere between 1 and negative 1, which also means that x is somewhere between negative 1 and 1. And you might need to think about that for a little while, but I think you should be able to figure that out. Now we need to check our endpoints. When we check our endpoints, we see that this top one is just 1 plus 1 plus 1 plus 1. It does not converge. We look at the bottom one. It is again 1 plus 1 plus 1 plus 1. It also does not converge. So we can say that our interval of convergence is from negative 1 to 1, and we do not need to include the endpoints. If you were to graph both your original function, 1 divided by 1 minus x squared, and your series of first 4 non-zero terms, now it wants 5. Well, anyway, we're just going to go with it. We're going to use the first 4. And you're going to look, and you're going to see that the closer you are to 0, the closer those two graphs are. It's really important that you do that on your graph right now so that you understand this walking into the AP exam. Or, I guess, opening up your computer for the AP exam. That's so lame. Okay, next slide. Find a power series for f of x equals 12 divided by 4 plus x, centered at x equals 0. Give the first 4 non-zero terms and the general term. For what values of x does your series converge to f of x? Well, first of all, this doesn't look anything like a geometric series, correct? But think again. We have 12, wrong tool, 12 over 4 plus x. How can we make that so that it looks something like 12 divided by 1 minus r? Well, we can make that x. We could make r negative x, and from there things kind of fall together, and you're going to see the first glimmer of what manipulating series looks like. And with only a tiny bit of trickery, you can see what R is. Now, think back again. Your A value will always be on top, and R is somewhere in there in that 1 minus, in the bottom, in a 1 minus R form. So we go in, and again, I'm going to jump to the series without doing the terms, and then I'll backtrack and do them for you. So we're looking from n equals 0 to infinity, and our A is 12, and our R is negative 3 minus x to the n. Okay, I want to talk about what just happened. I finished whatever I just finished at about 10:30 last night and made myself go to bed, and I woke up this morning at about 6, and I started recording at about 8, and it's now 9:45, and I'm getting really wrapped up in the nitty-gritty details. So I decided to skip the first 490 terms and come back to that because I feel like I need to get this video out in a timely manner. So here is your general term and the actual series with your R value. And I set the absolute value of R less than 1. If I did any kind of work, I can't rewind this tape. This particular software won't let me. If I did any particular kind of work on the actual individual terms prior to this, you need to ignore that because I am somehow getting really wrapped up in the details and I'm playing a little bit too much, and I need to stop that and stop wasting your time. So if I did that, I'm sorry. I can't edit. I can't rewind. I can't even see what I did until I completely finish this video. So here we go. I solved for X or I solved for X to figure out for what values of X does the series converge, and now I need to look at the endpoints. And we see that when X equals -4, we just have a series of 1 plus 1 plus 1 plus 1 plus 1 plus 1. So exciting. Okay, so when X equals -2, that is an alternating series that just bounces back and forth between 12 and 0. Therefore, it diverges by the nth term test for divergence. And the series converges on this interval from from -4 to -2. And you need to state that. Notice that I have clearly communicated that idea in writing. I did not just simply leave this answer hanging out here like it was the whole entire answer, because it is not. This right here is the whole entire answer it's not the whole entire answer. It is the entire conclusion. There we go. Correct words that time. Okay, so for some reason, I keep jumping to the series almost immediately in my head. So I had to write out the math to solve for R so that you could see that. That's going to be a key component in you being able to figure out what's going on. Always set up that inequality 1 minus R equal to whatever you see on the bottom of your power series where R is not given. Okay. So we go ahead and do that, and I'm not going to give the first 4 non-zero terms because, as I said, I keep getting really caught up in that. I am doing some really wild tangential things, and I need to stop, and you need to see this video. So I will make sure that I post that later in the day. And I'm so sorry. Tuesdays are my busiest day, and I'm trying to get these videos done on Thursday and Friday, and I'm really sorry. I'm really sorry, guys. But we're going to be able to make it through this. Even the teachers, I don't know if you know, it takes several hours to put together a 10-minute video. It's kind of nuts. Actually, I've gotten it down to about an hour most of the time. Okay, so anyway, here we go. We need to take the absolute value of R and set it less than 1 to figure out for what values of X does this series converge. Once you've figured that out, now you need to check your endpoints to figure out the actual interval. So you need to figure out what happens at 2 and what happens at 4. Okay, so the first one diverges because it's just bouncing back and forth between 1 and 0. And what just happened? 4 minus, that should be a 3. That's a 3. Doesn't look like a 3, does it? And the other one diverges because it's actually just 1, or actually 5. Actually, oh, I misspoke. The first one is bouncing back and forth between 5 and 0. The second one is bouncing back and forth between, oh no, it's not bouncing back and forth. It's 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5. So that's boring to listen to, so I'll stop. But both of them diverge. So your actual interval of convergence is from thinking about the wrong one, 2 to 4. Okay, I am going to stop there. We do have, oh no, I can't stop there. Never mind. I'm sorry. Okay, but the rest is way less complex. So here we go. Okay. Or I get distracted less easy. Let's put it that way. Here we have something that looks very similar to e to the x. Okay, so we have something that looks super similar to e to the x, except instead of x, we have dun 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 3. I hope you can see that in every single spot. Oh my gosh, what is this? This is just e to the 3rd. And there you go. Beautiful. So I don't know if you can hear the music I'm listening to, but it is really bizarre. I decided I was sick of classical music and I don't like listening to words when I work, so I found this random playlist called Dinner Music, thinking that it would be nice and mellow in the background. And it is weird, weird, weird. Okay, so this next one you see looks an awful lot like the series for the sine of x. So hopefully you can recognize that. Hopefully you've been practicing really hard on your memorization. Do not save that memorization until the last night, dudes. My dude. Okay, so that proves that our actual series converges to sine of 2, and and then we get down to our next one, and we see, hopefully you see, that is in fact a geometric series. And we just use the sum of a geometric series and we get 3/5. Next bit. And students get really confused on this part, so if you get confused on this part, please feel free to Zoom me. I will do my best to explain it to you. I happen to find this particular part really, I don't know why I don't find it difficult. Maybe it's because I've taught series for so long. I don't know. But anyway, what we see here is that we've got a power series that converges if x equals -8 and diverges if x equals 6. What you should be able to see right away is that it's centered at -3. So that means several things. Okay, so what that means here is it converges at -8, which is 5 away from the center. Let me see if I can draw this. So we're going to go 5 away from the center. Nope, can't draw it. Let me see if I can do it. Oh no, I tried to lasso it. -8 to 2. That just bites. Why doesn't it work? Now I'm going to, okay, I'm going to stop. Okay. I really wish I could do that. I'll try a box. Okay. That is booty. There. That's 5 away. Okay, we know for sure that it converges 5 away from -3. We also know for sure that it diverges. What is that? 9 away from 3? -3. -3 plus 9 is 6. Yep. Okay. So we know that it diverges 9 away from -3. So we don't know what's going on in the, I think this is Miley Cyrus singing. We don't know, oh gosh, what's going on in this interval or this interval. Oops. There, that bit. We have no idea what's going on there. And actually, this bit should be going back a little further. But anyway, I digress. So we go in and we know that the power series may converge if x equals -10, because that's in that little bit that's technically between the two pink boxes, even though I made my two pink boxes. This pink box I didn't bring back far enough. So we know that it may converge there. We also see that the power series converges if x equals 1 because it's in the first pink box. I'm sorry, I'm referring to this by color. Somebody's probably colorblind. Oh, gosh darn it. I can't write today. And we also see that the power series definitely converges if x equals 2 because it's in the little radius that we know for sure exists. And the power series diverges if x equals -9. That's in that little area where we don't really know what's going on. So it may or it may not. So we write may. What about at -13? Well, -13 is way beyond the scope, and let me make a more appropriate box here. We need to go 1, 2, 3, 4 away, and I'm only 2 away, so we're going all the way down to -3 plus 9, -3 minus 9. -3 minus 9 is -12. So we have this whole big area in here, all the way from -8 to -12, where we have no idea what's going on. -3 minus 9 is -12. -3 plus 9 is 6. Okay, I did it right. I'm so afraid of making a stupid calculation error. Okay, so there we go. We know all of this, and we know that beyond this outer box, we know that the power series definitely diverges if x equals -13. So this must be true. Oops, wrong tool. Must. Boop. Okay. Now we're going to examine the radius of convergence and the interval of convergence quite a bit more, and we are going to create the Maclaurin series for the function, and then we're going to give the first 4 non-zero terms and the general term. Okay, so we go ahead and find our Maclaurin series. We find all of our derivatives at 0. We find we put it into our Maclaurin series, which by now we should have memorized, and we discover that 1 over 1 minus x is equivalent to 1 plus x plus approximately equivalent to 1 plus x squared plus x cubed plus plus x to the n. So we can actually write that as a pretty series using summation notation, which you shall see on the next bit. Okay, I almost accidentally did that whole thing without recording again. Here we go. Here we go. We got this beautiful series, and we need to figure out what r is. R is actually x, and we just need to set the absolute value of x less than 1 and solve for our radius of convergence. Once we've done that, we need to check our endpoints. There's our radius. Actually, our radius is 1. Our center is 0. Let me see. We need to figure out for what values of x does the series converge. So what we really need is the interval of convergence. So we need to find out what happens when x is -1. When x is -1, you should be able to see that when x is -1, your values are simply going to vacillate between -1 and 0. And when x is 1, you're just going to end up with a crazy growing series. So this actually is your interval of convergence right here. And I gave the first 4 non-zero terms and the general term. Next, we're going to use our answer to B to find the sum of the infinite series below. So as you can see, we have found something that is a little annoying, but we can take the derivative of it, and I think, give me a second. Okay, this piece I have a really hard time explaining. I'm sorry. If you use your imagination a lot, these two things are equivalent. So what we are really looking at down here is actually B. So we are looking at the derivative of f of x. So coming back there, if we have f of x, let me get f of x equal to, what was it, 1 over 1 minus x? Oh, I forgot my x. Of x. And what we are really looking at is f prime of x. And because I'm a weirdo and I can't stand quotient rule, I'm going to rewrite this. I didn't need to do that, did I? 1 minus x to the negative 1. So that means f prime of x would be 1 minus x to the negative 2. And what we are looking at here is f prime of x, but we're actually looking at f prime. Oh, that's fancy. F prime of 1/3. So our actual sum is 1 minus 1/3 to the negative 2. And I'm going to leave it that way in the interest of time. If you were taking an AP exam, whether it would have been during this crazy time, or even if it had been a normal time, you would leave your answer that way. A numeric answer is a numeric answer, is done. Understood? Don't waste your time doing those calculations. Next bit. Onwards and upwards. We are going to write the Maclaurin series for f and give the first 4 non-zero terms in the general term. For what values of x does the series converge? And then we're going to integrate it. Okay, so we go through all that and we see that this is where it converges, and those are the first 4 non-zero terms. And if you're me, you realize that you forgot to talk about where does the series converge all the way back on this page. It converges from negative 1 to 1, not including negative 1 and 1. And if you don't understand why it doesn't converge on negative 1 and 1, you need to go through and plug in negative 1 and 1 for yourself and try that out. And if you still don't understand, you need to Zoom me. Okie dokie. There we go. We are going to use our results, to, what's happening? Weird screen. Okay, we're going to integrate that and find the first 4 non-zero terms in the general term. Okay, I'm getting a little bit nervous because not a single question has asked for the radius, for you to state the radius of convergence. So in this particular problem, I am choosing to state what the radius of convergence is. The radius of convergence here is 1 with a center of 0. So I'm looking at each of the endpoints being negative 1 and 1, and seeing if they are included in the interval of convergence. If you look at this first bit, on this first series here, this is the alternating harmonic series, and that converges. And the second one is the harmonic series, which does not converge. You are expected to know that. If you have to, if it really wants justification, pay close attention to what kind of justification they want. These two you should know by heart. And most of the time they're just going to expect you to know that the alternating harmonic series converges and the harmonic series diverges. So then we go in. Crap, I've got a faculty meeting in like 5 minutes. And you can actually write down the interval of convergence, which is what they're asking for in the problem, even though it doesn't actually say that they want the interval of convergence. That is what is meant by for what values of x does the series converge. That's the question I'm answering right now. Okay, so we have this as our interval of convergence. And apparently that is all the question asks. So we go down to the next one, and we are using our answer to B to find the sum of the infinite series below. And we can just replace x with its value. And that is just 1/3. And I couldn't read my own handwriting for a moment. And we get 2/3 to the -2. This is a weird song. Okay. I'm going to put that on pause. That's uncomfortable. Okay. Sorry, that was strangely distracting. Squared equals 9/4. Okay. Oh my gosh, longest video ever. Yay. I'm done. I do need to go back and do those few problems, but I don't have time right now, and you guys are somebody's probably awake and waiting for me to post this, and I'm so sorry. Y'all have a good one. I miss you terribly. Oh my gosh, we are almost done with sequences in series. After we complete sequences in series, we need to go through polar and parametric, two things that you are very weak on because you did not cover it sufficiently in pre-cal, and you will be embarrassed in college if you do not understand polar and parametric. So your motivation for doing those two is just to kind of save face when you get to college. Understood? Okay, but between now and the AP exam, we're going to focus on reviewing for the AP exam. And then we get to sigh a big, huge sigh of relief as we enter into the polar and parametric realm. Polar is pretty hard, but I think with the new timeline, I think that we can take some time in it and explore it a little bit and explain it with more thoroughness than I've ever been able to do. Parametric's pretty easy. You're just going to be embarrassed if you don't. Which is going to make it more embarrassing if you don't know what's going on. Okay. I miss you. I was going to tell a joke, an actual intentional joke during this thing, and I totally forgot. And I need to go back in and flesh out the first non-zero terms for those two problems. I'm so sorry, and I'm so sorry this stupid thing is 35 minutes long. Oh my gosh. Y'all are my heroes, rock stars. Take care. I miss you. Bye.